Okay, we're going to approximate natural log of 1.09. We're going to use f of x equals natural log 1 plus x. And, well, they even give it to you. I'm sorry, we don't have to find it. They give it to you. P2 of x equals, we don't need to do this problem, but since I started it. So they give you P2 of x. They did not make you find it. We would have centered it at 0 because the x piece of this is only the 0.09. It does not include the 1. 0.09 is very close to 0, so we would have done it with a equals 0 to find that, okay, if we had done that out. So all you have to do here is put 0.09 in for x over there. Go ahead. I'm not going to do it this time. Get out your calculators. Find for me P2 of 0.09. They want it to 4 decimal places.
Yeah.
And so it says here 4 decimal places, so we're going to round the 9. We look at the next digit, 5, that bumps it up to a 10. And so you got to carry your 1,680.0. All right. So there's your second degree polynomial approximation. Now we need to find the absolute error. So absolute error will be the absolute value of natural log of 1.09 minus our decimal approximation 0.0860. I assume it wants the rounded value in there, but it does not. It says do not round until the final answer. Maybe it does not want the rounded value. I'm sorry. It said do not round till the final answer. So I think is this as far as the calculator went?
Yeah.
So we should use that. Oh, wait a minute. I'm looking at a different one. Hang on. You just need to see what I'm looking at here. I was reading this, which wanted that first answer, 0.0860. Okay. Now, absolute error says use scientific notation, use the multiplication symbol. Probably not going to matter because we're going to round it to 2 decimal places. I don't know if it's going to matter. Yes, it would matter. All right, what do you get if we use the original?
The last problem I rounded it up and used it. So
What's this? You don't know?
Scientific notation.
Yes, we're going to need that. I'm putting it in here.
2.28 times.
Wait, oh, the rounded one did work, huh? Yeah. But they don't, well, we're kind of not trying to avoid
You
it.
say 2.28?
Yeah, 2.28.
7696.
Okay, so why do these things always have to be confusing? So we're getting here 0.000227696 in the calculator. So in scientific notation, put the decimal there, 2.2 the 6 rounds the 7 up to an 8, and times 10 to the 1, 2, 3, 4, so -4. Now here's the dilemma. I don't know if Pearson is using this number to get this, or if they're using that number rounded to get that. Do you hear what I'm debating here? Now, does it matter? Yeah, it's gonna change that digit, isn't it? Which is the third, so let's do it with this. If it's wrong, then we'll do it the other way. 2.28. There you go. Work.
I'm not on this explanation, but when we do the calculation, when we put the .09 into the formula, how can we not use one, like how can we not do the 1.09, we just do something else?
Good question. It's because they have the 1 here. And so the x, to get this,
Oh, okay.
the x would be the .09.
That makes sense.
And so we're only putting what x would be into there.
To make up for,
Yeah.
okay.
So that's why we did .09.
Got it. Thank you.
Good question. And when the very first time I taught this, that really hung me up. I kept putting 1.09 and it didn't work.
So for instance, like if the function was just ln of x, then we would use the 1.09?
Yes.
Okay. Okay.
Yes. Any other questions? Yes.
You said we would use 0 because .09 is closer to 0, but if it was .9, we would use 1.
Then 1 would be a better choice. Yes. Once you get over 0.5, I don't know, it depends on the graph, because these curves, so they're not linear. But yeah, you want to use something that's close to center it for A. All right, any other questions about this? Let's move on here to section 11.2. What does this one do? Do the 28th tomorrow. Okay, I'm gonna move the due date back.
Done.
Make this due. Wait. Yeah, 28th, there it is. We're gonna make this due Thursday. The 30th. So, Wednesday will be the last chance to ask questions in class before it's due, all right? Okay, moving on.